Hold on tight, folks. A gigantic dust cloud from the Sahara is spreading across Europe this week, transforming our skies into a spectacular natural spectacle. We explain how desert sand from North Africa reaches Europe, why it causes blood rain and sundogs, and what will happen to air quality here.
So make sure to stay tuned until the end if you want to be prepared for the coming days. A warm welcome, everyone.
When I tell you that a huge cloud from the Sahara is heading towards Europe, it sounds like the plot of a disaster movie, but don't worry, it's not the next biblical plague, it's Sahara dust. And if you want to stay up to date with all the exciting natural events in the future, subscribe to the channel now. Subscribing is free, you'll never miss a video again, and you'll be helping me out a lot.
If you've already subscribed, giving the video a thumbs up really helps. 5,000 likes is the magic threshold for the YouTube algorithm. Thank you very much, everyone. Yes, the Saharan dust already reached Europe on Monday.
First it hit Spain and Portugal, then Italy and France. From Friday, Germany will also be completely covered, and that means the sky could change color significantly. Anything from milky and cloudy to yellowish to intensely reddish is possible. Sunrises and sunsets in particular could be truly spectacular.
So, this is your chance to get an Instagram photo that gets more than 3 likes.
Boom. Roasted.
But where does all this dust actually come from? Well, with around 9 million square kilometers, the Sahara is the largest hot desert in the world.
And contrary to what many people think, it's not just endless sand dunes. Large parts of it are what are known as gravel and dust deserts. There, extremely fine sediments lie exposed on the surface. Remnants of lakes and river systems that existed thousands of years ago when the Sahara was still green. These fine particles are the key to the whole phenomenon. When strong winds sweep across the dry ground, tiny dust particles are lifted into the atmosphere, and we're really talking tiny here. Most particles are only a few thousandths of a millimeter in size, so small that they can easily enter our lungs through the nose. This happens particularly efficiently in the Baudelaire Depression in Chad, one of the dustiest areas on Earth. There, local wind channels act like natural jets, blowing enormous amounts of material into the air. It's like a giant leaf blower, but in this case, more like a dust blower.
At times, over 700,000 tons of dust are stirred up here and hurled into the atmosphere every day. That's roughly equivalent to the weight of 140,000 elephants just flying through the air. Luckily, it's not actually thousands of elephants flying from Africa to Europe, but just dust. Although I have to say the idea is kind of funny. Hey guys, quick request. YouTube is currently being flooded with hastily thrown together AI content, so-called AI slop. This isn't meant as general AI bashing, but it does make it harder for human creators to stay visible. This video here is not AI slop. It was researched, written, and produced by hand by several people who make their living from this. An editor, a video editor, a marketer, and myself. If content like this matters to you, your subscription helps us tremendously. Every subscription to the channel ensures that we can continue to put time and energy into real, carefully crafted videos. Thank you so much, everyone. And now, let's continue. Now you might be asking yourself, okay, Tim, but how does this dust manage to travel several thousand kilometers all the way to Europe? The answer lies in large-scale weather patterns.
The decisive factor is the combination of low-pressure areas over the Atlantic and high-pressure areas over North Africa or the Mediterranean region. A powerful low-pressure system west of the Iberian Peninsula generates a strong south to southwest flow. This then acts like a conveyor belt, transporting the dust-laden air from the Sahara across Morocco, Algeria, and the Mediterranean to Spain and Portugal. From there, the dust cloud spreads further to France, Italy, and finally to us in Central Europe. And how does this result in a yellow or even red sky? The sky changes color due to a simple physical principle: the scattering of sunlight. The dust particles in the atmosphere act like tiny mirrors and filters. Shortwave blue light is scattered more strongly, while long-wave red light appears more dominant. We are familiar with this from normal sunsets, but the additional dust greatly intensifies the effect. So-called sundogs can also appear. These are light phenomena that are normally caused by ice crystals in high clouds, but become even more spectacularly visible due to the additional particles in the atmosphere. Small reflections can be seen next to the rising sun, like miniature suns to the left and right of the real sun.
And now it gets even crazier. In Spain and Portugal, so-called blood rain could occur this week. The term sounds dramatic, as if the sky was suddenly weeping blood.
Historically, such events were often interpreted as divine signs or omens of disaster. Ancient chronicles contain reports of blood falling from the sky. No wonder people panicked back then, but today we know better. It is a relatively simple phenomenon. When it rains, dust particles are washed out of the air, the rainwater mixes with the reddish desert sand and leaves a reddish-brown layer on cars, windows, or terraces. The reddish color comes from the high iron oxide content in Saharan dust. Chemically speaking, it is simply rust. From Tuesday to Friday, people in southern Europe can expect this phenomenon. Further north, blood rain is relatively unlikely as the weather conditions look very dry. Instead, the dust is particularly noticeable in the atmosphere with the intensely colored sunrises and sunsets we just mentioned. But why does the dust remain in the air for so long? As we already know, the dust particles from the Sahara are extremely fine, often only a few micrometers in size. This allows them to rise several kilometers high into the troposphere, where they are transported further by strong high-altitude winds known as jet streams. As long as there is no rain to wash the particles away, they remain suspended in the air. A stable high-pressure area, such as the one we currently have over Central Europe, further intensifies this effect. High pressure causes air movements to sink and reduces vertical mixing. As a result, the dust accumulates in certain layers of air, and this brings us to an important point: air quality. Even though Saharan dust is a natural phenomenon, it affects the air we breathe. The fine particles increase the concentration of particulate matter in the air. This can be particularly noticeable for people with respiratory diseases. In addition, high-pressure weather conditions often mean that local pollutants are less easily dispersed. The combination of Saharan dust and stagnant air can therefore lead to a significant deterioration in air quality, so for anyone with sensitive airways, it might be a good idea to stay indoors for the next few days.
No problem for me. A few days ago, I reactivated my World of Warcraft account. So if you don't hear from me anymore, now you know why. Only if there's a change in the weather after the weekend and the clouds clear will the air potentially become clearer and fresher again.
But interestingly, Sahara dust is not only a nuisance, it is also an important part of global cycles. Hundreds of millions of tons of dust are transported from the Sahara every year. Some of it even reaches the Amazon in South America. There, the mineral-rich dust provides valuable nutrients such as phosphorus, a crucial fertilizer for the ecosystem. Crazy, right? The Sahara is essentially fertilizing the rainforest on the other side of the Atlantic. The dust also influences cloud formation, the radiation that reaches the surface, and even hurricane activity in the Atlantic. So what appears to us to be a short-term weather event is in fact part of a complex global system. It is precisely such connections that show how incredibly interconnected our planet is.
Of course, I'll keep you updated on any further developments. So feel free to subscribe to the channel now so we can hit 400,000, and don't forget to give a thumbs up for 5,000 likes.
And while we're on the subject of spectacular natural phenomena, scientists have discovered a gigantic gravitational anomaly beneath Antarctica that could completely change our understanding of Earth's gravity. What is causing such an anomaly deep beneath Antarctica? You can find out in the video displayed at the top right. Be sure to check it out, it's very exciting. As always, there's another video about science and space at the bottom right. Otherwise, I'd say see you in the next video. Take care, everyone.